one thing that we can talk about when we think about phases is we can think about phases in terms of solubility. Right? And kind of one of the examples that we use when we're talking to students is we talk about the idea of having, say, temperature on one axis and having this be water. And then having this be the weight percent sugar that's been added to the water. And as you have, this glass of water, and you're putting sugar into that, you start putting sugar in and it goes into solution. Okay? Goes into solution, keeps going in. Well, at some point, we stop going into solution and instead we start to precipitate out sugar on the bottom. And that point represents a change, where here is water. And that's a solution. And on this side, we have water and sugar. And we know that as you increase the temperature, you get greater solubility. So if we go up in temperature, we're going to have something that does say that. And as we go down in temperature, we lose solubility. And if we get below a certain point, we actually are going to have some type of freezing. Ice. It's probably going to be ice and sugar down here. But we're essentially then marking out regions of space. And in this space here, we have water and it's having sugar put into it. Here we have two phases, water and sugar. And here at the low temperature, we have ice and sugar. And that's kind of one picture of solubility. Another solubility concept that you can think about is oil and water. And I like oil and water because it kind of demonstrates a little bit of what we think of as the in the dilute limit. So if we have a phase diagram here, and here we have water being mixed together. Well, if you imagine, again, you got some glass and you got oil in it. Well, you can put a few molecules of water in and they don't separate out. They get completely immersed. And in fact, you can probably put more than just a little bit, but it's going to be the limit. It's going to be pretty much over here somewhere. And the same thing's true over here. You have some water, you put a couple of oil molecules. The oil molecules don't immediately agglomerate. Instead, you have still some solid solution. And it's going to go up kind of like this in temperature. So you're going to wind up with a region here of water, solution, a region here of oil, solution. At both these endpoints, we have pure oil and pure water, and in between, we have a mixture of oil and water, a two-phase solution. So this type of phase diagram is something that you can read from. And the same is true for a crystalline solid. For example, if you were given a phase diagram that looked like this temperature versus, say, whatever, some element A. I don't know what that is. We'll just now consider some AB compound. If you had a phase diagram that looked like this, and we will talk about this phase diagram later, liquid, alpha, alpha plus beta, alpha plus liquid, beta plus liquid, beta. So reading from this phase diagram, what you should see is at any given temperature, for example, here, you can say what phases are present. Well, it's alpha plus beta. If I change the temperature, say up to here, now it's alpha plus liquid. If I change the composition, say it over here, now it's just liquid. Beta plus liquid. Alpha plus beta. Beta. And these alpha and betas, they are solid solutions. This is something that contains a little bit of element A, a little bit of element B. Now, in contrast, right on this line, that's pure A, and right on this line is pure B. But again, thinking about solid solutions, this just has to do with the fact that, if you have a pure crystal of B atoms, and you've got some pure crystal of A atoms over here, right? And they're different crystal structures, perhaps. Right? Say a tetragonal versus a cubic. Well, naturally, you can't completely intermix them because they have different structures. But you can certainly replace some of the B atoms with A, and you can certainly replace some of the A atoms with B. Now, I should comment here that I call these elements. I just said that as a matter of convenience. They actually can be complex compounds. They don't have to necessarily be pure elements. So, for example, that phase diagram we had of oil and water, well, that's not a single atom or element of oil, but actually it's a compound. And what we have are compounds that are uniquely identified, and you want to think of them as stoichiometric compounds on either end, and then we can have alloys with those, or solid solutions.